Hello, and welcome to my little mini lesson on absolute value. Absolute value isn't typically taught in the UK early on, whereas in the US it's taught pretty much early in high school, and it does show up significantly on the SAT and the ACT. Well, by significantly, I mean you'll see it a few times per test. Okay, so what is absolute value? It's not terribly tricky, but it's just a few things you have to learn in order to know what to do with it. Absolute value, we'll recognize it straight off. It's the absolute value of x here. It's these straight lines outside encasing this x. What does it mean if I say, what is the absolute value of 3? All right. Well, the concept behind it is that it is the absolute value of something is the distance of it on a number line to 0. So for example, what's the distance to 0? The absolute value of 3 is what is the distance to 0 is 3. Well, it seems pretty obvious. It's 3. So the absolute value of 3 is 3. Pretty easy. Okay, and again, what's the absolute value of minus 3? Well, again, what is the distance from minus 3 to 0 on the number line? And again, the distance from minus 3 to 0 is 3. Okay, let's try a couple more. What is the absolute value of 25? The distance of 25 to 0 is just 25. And what about the absolute value of minus, let's say, I'm not going to write this out, but 1 million. And it's simply the distance on the number line from minus a million to 0 is 1 million. Now you'll probably notice here that the absolute value of something is always going to be positive. And why is that? Because we can't have a minus, you can't have a negative distance, can you? It's got to be positive. Okay, that's the concept of absolute value. But you're not going to see anything quite so easy, unfortunately, on the SAT or ACT. What you will see, though, are possibly equations using absolute value. Now, like here, the absolute value of x minus 3 is equal to 6. Now, if you think about it, there's going to need to be two answers to this because you're talking about there's two different values of that x can be that the distance to 0 is going to be 6. There's going to be two answers. So that means you've got to set this equation up twice. The first way to do it is the most straightforward. You just get rid of the absolute value signs and solve for x. So we've got x minus 3 equals to 6. If you add 3 to both sides, you get x on its own. Add 3. You get x equals 9. Okay, second way. Next step. You copy down what's inside the absolute value, the x minus 3 again, as it is. But now you take the second side of the equation, and whatever sign it is, in this case it's a positive 6. Now, whatever it had been, you flip it. So if it was positive, it's minus. So it's going to be minus 6. Or if it had been minus, it would then be positive. So if it had been a minus 2, it would become a positive 2. Okay, and then you solve for it. So again, I'm going to add 3 to both sides. I'll do it down here. So put plus 3, and I solve for x. So x is left on its own, and I've got it right here. X equals minus 3. Again, remind yourself there's going to be two possible answers. So x is going to be 9. And x is going to be minus 3. And let's think about it. If I go back up in here and I say 9 minus 3, the distance of 9 minus 3 is to 0 is 6. And minus 3 gives us minus 6, which is also a distance of 6 to 0, if you want to get a hold of the concept behind it. Okay, so that's the basic equation. Now there's one other extra step for inequalities. Okay, so let's look at this one we've got here. Here we've got the absolute value x minus 3 is greater than 6. So slight difference here. Okay, first step, first way we solve it, again we need two answers for x. Again, the first way stays exactly the same. So I've got x minus 3 is greater than 6. So I'm going to solve for x again. Add 3 to both sides, which gives us x is greater than 9. Okay, next step. Again, you just copy down the bits that are inside the absolute value sign. So I've got the x minus 3 here. And I flip the sign, as same as before. I flipped the sign. Before it had been a positive 6, and now it's a minus 6. But now there's an extra step. Notice that it's greater than here. I need to flip the sign as well. So if it's greater than in this one, it needs to be less than here. Okay, so we've got it set up now. We've got our equation as x minus 3 is less than 6. So let's solve for x, same as before. I add 3 to both sides, which will give me then x is less than 3, minus 3 rather. So if I'm going to put this on a number line, not very tidy number line, apologize. X is greater than 9. So at 9, it's greater than, I do like something like that, make it a little clearer. It's greater than 9. And x is, here's minus 3. X is less than, maybe a little arrow, all the numbers less than minus 3. Okay, not too bad. One last little reminder, I just want to remind you, you've learned this in the past, but SAT does tend to pick up on things that you haven't done in a while, ACT as well. Let's go back to solving for inequalities. I've got this little equation here, minus 3x is greater than 9. Okay. When you're solving for x here, in order to solve for x, I've got to divide both sides by a minus 3, don't I? Now, if you recall the rule for this, if you're dividing this side in an inequality by a minus 3, by minus a negative number, you need to flip the sign. Another flipping going on here. So it's changed from this to a less than. Okay. That's the basics of setting up solving for an inequality. One last little thing I'll mention, let's say just absolute value of 2x plus 3 equals 6. Again, if you're solving for x, I didn't do a two-step problem. Again, you set it up both ways. Just this is an extra, you got a 2x plus 3, not an x plus 3 on its own. Again, you set it up, it's basic algebra. The two ways I'd set it up, 2x plus 3 equals 6. Solve for x. 2x plus 3 minus 6, flip the sign. I just wanted to show you a two-step problem. It's set up the same. Okay, last thing I wanted to go over is an absolute value graph. Okay. Now don't let this scare you. It's not too bad. I've got here a function here called g of x. Now let's just remind ourselves that the x and y values, let's just remind ourselves, the x value is what's inside here. So the x is inside the parentheses, and the whole thing is the y value. Okay. So the x values run this way, and the y values run this way. Now, what if they said, and this you might see on the ACT or the SAT, what is the absolute, which graph would be the absolute value of g of x? Okay, let's remind ourselves the absolute value cannot be negative. It must be positive. So it means looking at now this and the g of x, that is the same as the y value. So here we need to look at this part of the graph, and everything needs to be positive. So this is all the positive values of y, and these are the negative values, aren't they? So the absolute value takes anything that's in the negative area and I say, bounces it up. It makes it go into the positive. So what did that look like? Let me scroll down and show you a graph. Okay, there you can see it. So if this is g of x, and this is the absolute value of g of x, you'll see that anything that was negative up here has bounced up into the positive area. So it's all looking positive, very hilly. Anything that was already in the positive stays positive. Anything that was negative comes up here. There aren't too many of these kind on there, but it's just something I wanted you to become aware of. Right. And that concludes our absolute value mini lesson.